Welcome to this quick tutorial video. Please grab a pen and a piece of paper, and if you can also open your book, chapter 13, question number 82 at the end of the chapter. I'm going over this question very fast. We are calculating the molar mass of an unknown compound. The only thing that we know about this compound is that this compound is nonelectrolyte. It means that the Van 't Hoff factor is going to be 1. So let's read this question for now. A dilute aqueous solution of an organic compound soluble in water is formed by dissolving 2.35 gram of the compound in water to form 0.250 liters of solution. The resulting solution has an osmotic pressure of 0.605 atm at 25 degrees Celsius. Assuming that the organic compound is a non-electrolyte, what is its molar mass? Okay, so it seems like very easy because I can give you the formula for molar mass, and we can also calculate the molarity, and it's so easy. But this question can become nasty enough to have you fail a test or not get a good grade on an assignment when this compound is actually is not a non-electrolyte. If it's an electrolyte, then you should be very careful because you are also dealing with Van 't Hoff factor. You have to know what the Van 't Hoff factor is. So because the compound is unknown, so you don't know what the Van 't Hoff factor is, they have to give it to you. So it's very unlikely on a test that you receive a question like that. But another variation of this question is when they are giving the osmotic pressure in torr. Okay, so you have to, okay, let's say it one more time. You have to change torr to atm before starting. Okay, so and you know that atm is just torr divided by 760. Okay, so for example, just in case if they have given you this value 0.605 in atm, instead if they had given this in torr, okay, then you would have to change it to atm before starting. So let me very quickly change this to torr to tell you exactly what's happening here. Okay, so let's say the osmotic pressure is given in torr instead of atm. Okay, so imagine that they have given the osmotic pressure as 459.8 torr. Okay, so then you have to divide this value 459.8 torr by 760 to get 0.605 atm. Okay, which is the osmotic pressure that you can use in the formula. Okay, so and the formula for molar mass of a compound is the mass of the compound in gram divided by multiplication of the molarity of the solution and the volume of the solution in liter. Okay. So the molarity of the solution, you can calculate it by, so molarity is osmotic pressure, okay, divided by gas constant times T. T is the temperature, okay. So what I can do here in that original formula here, so instead of type in molarity, I go ahead and put osmotic pressure divided by RT. And if just in case if you are given the Van 't Hoff factor, you have to put Van 't Hoff factor in here, actually in the denominator of the new fraction at the bottom of this fraction, okay? But it's very unlikely. Just in case, I just put it with a different color here. That's the Van 't Hoff factor. If you're given, put it here, okay? Otherwise, you don't have to be worried about that. Okay. Okay, now you're ready to solve this problem. It's so easy. So just plug in the numbers, okay, and use your scientific calculator. And you're very lucky that you are allowed to use scientific calculator at college level because it makes life so easier. So molar mass, oops, let me change the color. So molar mass here is equal to the mass of the compound in gram, which is 2.35 gram, divided by, okay, so write a new fraction in the denominator. On the top, put the osmotic pressure in ATM. Okay, so I'm saying ATM, which is actually, what's the value? What was the value? Let me see. Oh, okay, 0.605. 0.605. Okay. And on the denominator of this new fraction, R, or the gas constant that we are dealing with, is 0.08206. 0.08206, okay, times temperature, and the temperature has to be in Kelvin. Okay, so let me also write it here with a different color. Kelvin. Okay, so the temperature has to be in Kelvin. The temperature has to be in Kelvin. So, and how you change it to Kelvin? So if it's like 25 Celsius, it's actually plus 273.15. That will give you the Kelvin temperature, okay? And then this fraction on the bottom of the original fraction will be multiplied by the volume of the solution in liter. So the volume of the solution is 0.250 in liter, okay? But let me tell you something. If they are giving you the volume of the solution in milliliters, you have to change it to liter, okay? And how can you do that? For example, if they say the volume of the solution is like 250 milliliter, okay, you will have to write it this way: 250 divided by 1000, okay? So we are working in this formula with many fractions, okay? But for the sake of simplicity, so let me just write it as it is mentioned here in liter, 0.250, okay? Okay, so just plug in the fraction in the calculator and the answer should be, let me see. Okay, so the answer is 380.136 gram per mole. Okay? Okay, thank you for watching.